a battleship that is 6.00 times 10 to the power of 7 kilogram and is originally at thrust fires a 1.10 times 10 to the power of 3 kilogram artillery shell horizontally with a velocity of 575 meters per second. If the shell is fired straight aft towards the rear of the ship, there will be negligible friction opposing the ship's recoil. Calculate its recoil velocity. B. Calculate the increase in internal kinetic energy. That's for the ship and the shell. Alright, so what's given here? We are given the mass of the ship. Let's represent it by m sub s. That's 6.00 times 10 to the power of 7 kilogram. Originally at thrust, that means its initial velocity is 0. And there is a mass of the artillery shell given. Let's represent it by m sub a, 1.10 times 10 to the power of 3 kilogram. And its velocity definitely 0 initially because it was mounted on the ship. It's equal to 0. The velocity of the artillery shell after it was fired, assuming its final velocity, let's represent it by VA sub F, and that's equal to 575 meters per second. Alright, so what is A asking for? What the recoil velocity of the ship is. Let's represent it by V sub SF. That's what we are required to find. Now, so what relates the masses and the initial velocity to the mass and the final velocity of the system? And that is momentum. Initial momentum must be equal to final momentum. And initial momentum is mass of the ship multiplied by the velocity of the ship initially plus mass of the artillery shell times the velocity of the artillery shell initial must be equal to mass of the artillery shell, or mass of the ship first, velocity of the ship final, plus mass of the artillery shell multiplied by its final velocity. Now, we know all the values except for the final velocity of the ship. We know that initial momentum of the ship is 0 because its velocity is 0 initially. The same thing with the artillery shell. Its velocity is 0, therefore this is going to be 0. So initial momentum is 0. Final momentum has to be 0 too. Therefore this is going to be ns VSF plus mass of the artillery, velocity of the artillery final. Now you can subtract mass of the artillery ship multiplied by its corresponding final velocity from both sides. That yields mass of the ship, velocity of the ship final is equal to negative mass of the artillery shell, velocity of the artillery shell final. And from that we can just divide both sides by mass of the ship, and that yields negative mass of the artillery shell divided by the mass of the ship multiplied by the velocity of the artillery ship after it's fired. That means final velocity. So the velocity of the ship after the artillery is fired will be equal to Let's plug in the numbers. Mass of the artillery shell 1.10 times 10 to the power of 3 kilogram divided by the mass of the ship, which is 6.00 times 10 to the power of 7 kilogram multiplied by the velocity of the artillery shell final, that is 575 meters per second. That yields velocity of the ship after the artillery shell fired will be the recoil velocity of the ship, and that's going to be 0.015 meters per second. 0.5 meters per second in the opposite direction to the artillery shell. That's the recoil velocity of the ship. And B is asking for changing kinetic energy. An increase in kinetic energy. An increase in kinetic energy means basically final kinetic energy minus initial kinetic energy. Kinetic energy final minus kinetic energy initial. Alright, so kinetic energy final is equal to kinetic energy of the artillery shell final plus kinetic energy of the ship final minus 0, because initially the velocities of both the ship and the artillery were 0. So basically the increase is going to be the sum of the kinetic energy final of both the ship and the artillery shell. Let's plug in the numbers. Let's write down first the kinetic energy formula for them. 1/2 mass of the artillery shell, velocity of the artillery shell squared, plus 1/2 mass of the ship multiplied by the square of its final velocity or recoil velocity, and that's minus 0. Let's plug in the numbers. Delta KE will be equal to 1/2 mass of the artillery shell, which is given to be 1.10 times 10 to the power of 3 kilograms, multiplied by the square of its velocity, which is given to be 575 meters per second, squared, plus 1/2 mass of the ship, which is given to be 6.00 times 10 to the power of 7 kilogram, multiplied by velocity, which is negative 0.105 squared. Therefore, delta KE, change in kinetic energy or an increase in kinetic energy, is equal to 1.82 times 10 to the 8.